We came here with one single purpose. We want to challenge a driver, and it's one of the best drivers in the world.
We've had great challenges, AI versus, human world champions, whether it's in chess, whether it's in Go. This is an opportunity for AI to come out of that game environment, that controlled world, into a physical environment, and that's unique.
My name is Lucas Di Grassi. I'm a professional racing driver and also a member of the board in RoboRace.
We're developing a self-driving system that will drive your car. So we want it to actually be better than the human, and by better we mean more reliable, more safe. Here at the racetrack, we're given extreme conditions.
The ultimate aim is to prove out the software algorithms which we're going to use in our road vehicles. It's the same software stack which we'll see in the Arrival commercial vehicles. It uses the same means of developing a trajectory, mapping itself, localizing itself in the world.
It makes sense to compare the system against the driver to see, does this system bring some advantage to human being?
Every year we do a challenge, which we take myself against the self-driving algorithm.
The challenge is basically as simple as beating Lucas around the track. So he does a lap in the DevBot version 2, and we do a lap with the autonomous system, and we're going to try to beat his lap time.
It's a time attack, so Lucas will go out, we give him a full discharge of the battery, so he'll get 8 or 9 laps. He'll have to learn the track on the fly, and then we'll do the same with the software driver.
Okay, car's stopping this lap.
You need to be able to use all of the circuit, and you need to be able to use it as well as Lucas will. Start really wide before a turn, come all the way into the apex, and then out all the other way, the other side. If we can harvest all that data and process it, we get an understanding as we go round of what the grip is, how hard we can drive around each part, and if we can go faster on the next lap.
You're losing this last corner. Okay, the high speed we also lose a bit, but this corner is probably where you lose the most, is half a second. And this is where we need to focus now to make sure that we get a better strategy with the car.
Okay, launching in 3, 2, 1.
It didn't crash. He knew that was going too far and stopped. Actually, good job, guys.
What we learned last year was that the human is better in adapting. Lucas was way quicker than us to understand the actual track conditions and to adjust his driving.
He's pushing vehicle to its real limits. And what we learned, we realized where the limits itself, and we have to define them faster, quicker and safer.
What is very interesting to me is to set a standard that I can repeat year by year. The progress has been consistently closing this gap between human and machine.
Lucas, you can head to the track once they close the doors. Copy, off the curbs. Launching in 3, 2, 1.
So a few minutes ago I did some laps. It started to rain in between, so track conditions changed. So the team here just put the car out to do a few laps while the track is really wet, so at least we have a way of comparison with the standard track conditions.
And track is clear. Okay, oscillations look good, so we're going to let this one go.
We're just saying the differences between the drivers is the weather between each session, and matching that just shows you how far we've come with the software.
The most important takeaway is that we can't be better than the human in one type of environment. Like, we can't beat Lucas only when it's dry. What we really need to be ready is for changing environments.
What RoboRace is doing is really pushing the boundaries of autonomous driving to the limits of racing and motorsport. In a couple of years, the world will look back at what we are doing today as something that pushed this technology that eventually will change a little bit the world for a better, safer place in the future.